So hello there, and welcome to the channel. Today I want to start my discussion about demonstrations. Demonstrations are so powerful that, in fact, they're quite successful. There's a whole network about cooking. It's just demonstration after demonstration. There's something really compelling about watching someone doing something and then trying it yourself. So the inclination might be for some teachers against demonstrations might be, well, it's a lot of prep work, and it is. Like, doing this demonstration video is taking a lot more time and effort on my part than my usual videos, and it's going to be complicated. But at the same time, demonstrations are very engaging, and that's one of the things that teachers have to be thinking about is, how can I engage my students in something and help them think about it and consider it, even as we're struggling against the balance of our understanding. And the other thing is that you may be thinking of demonstrations like Mark Rober does them on his wonderful YouTube channel. I am in no way associated with someone as important as Mark Rober. He's an actual, I think, NASA engineer. He's very important. I am not important. And his demonstrations are remarkably entertaining and lots of fun because he's kind of a natural entertainer. But demonstrations aren't necessarily just for entertainers. In fact, sometimes demonstrations are so entertaining that you lose the essence of what you're supposed to be learning by being entertained. So even low-key demonstrations can offer opportunities to teachers, especially if they're not comfortable with just talking to students, that they want to have more direction in their instruction. So demonstrations do take prep work. I've already done this experiment once this morning, and I've done it before, not a lot. Tomorrow I'll do a demonstration that I've done a whole lot, and I have no idea how I'm going to film it or anything, so I'm under the gun. So demonstrations always put you under the gun. If I were teaching a class with this demonstration, I might ask students to go by my bench and write down everything they see there, and before we do the demonstration, have them hypothesize, guess, what's going to happen, what I'm going to do, and what I'm going to use to do it. You're going to have to ignore the phone because it's going to just keep ringing. So, what am I going to do, and how am I going to do it, and what's the result going to be? So, first of all, the list of things that are here on my bench. By the way, small trivia offering. When I started to try to do this presentation, I was like, why do they call them benches? Because, of course, I did a lot of work in science in high school and college, and I just automatically referred to them as benches, the tables in the room, and I didn't know why. And then I looked it up, and it's short for workbench. And of course, workbench comes from those ancient crafters. People like cobblers who put together shoes use little benches to make the shoes. So the bench, the workbench, is the name taken from older practices, which is kind of wonderful. So here's my experiment that I'm going to show you, my demonstration that I'm going to do. And even though I'm not a science teacher, and you may not be a science teacher, and this is pretty simple science, it may be of use to you because it'll give you ideas about how to do presentations that might present good opportunities in what you're doing. So here I have a tray, a candle with some matches, and a little candle holder, what I would call a bottle or a vase, a glass of blue water, and there's the color dye that I use to make the water blue, and my coffee cup. It's a reference to my teaching career and all the teachers I knew. My coffee cup is always here, whether I use it or not. That's just for me. That's my coffee cup is just for me. Now, let's go to our next part. You may have already figured out, okay, what she's going to do. She's going to place the tray in front of her. She's going to put the candle on top of it. She's going to light the candle and cover it with this bottle. Truth be told, I would have used a taller, clear bottle if I had one here at the house, but I don't. I just had to make do with this. But that leaves out one of the important ingredients, which is this blue water. So, one of the things that kids grow up knowing is that you need oxygen to live. And if you smother something, it will die. So, this candle, when it's lit, is going to need the oxygen. And I'm going to smother it by creating a sort of a pool around it. And I'm using the blue colored water so that it's easier for us to see. So here's my candle sitting in its blue bath, and I'm going to light it and put the bottle over it. And so we're going to try to guess, first of all, what's going to happen and how long is it going to take. So this is what it looks like. It's glass. How long do you think it might take for something to happen? We'll see. You know, sometimes people will say they're kind of against science. That's kind of a movement right now that people say they're against science. They're not against science. They're against opinions that they don't like, but that's not the same thing as being against science, and I'll prove it to you. Do they have a refrigerator in their house? They're okay with science. Do they have plumbing in their house? They're okay with science. And you might say, yeah, but. The reality is science has been around observing the world and trying to solve problems for thousands of years. And people who say that they're against science, they don't really mean it. They do believe that science has contributed to our lives. They live in houses with electricity. They pay attention to things, whether or not there's going to be oxygen. They teach their children not to put plastic bags over their heads. Nobody's out there living in a cave running around chasing animals with a stone axe. They believe in science. They just don't believe in things they don't like to hear. And that's entirely different than believing in science. Science makes mistakes. Chlorofluorocarbons, they made great propellants for sprays, but they poked a hole in the ozone. Scientists sometimes go headlong at things and should think more carefully and study more carefully, but that doesn't mean that they're up to anything. It just means they're human. Okay, here we go. Down goes the bell, and we start the timer and we say, well, how long is it going to take and what's going to happen here? Here we have our little candle sitting in our jar. One of the earliest scientists was a man named Archimedes, who lived over 2,000 years ago, and he figured out all sorts of things. He figured out displacement, which is that if you put something that doesn't float in water, it's going to move the water. Ooh, now let's look at what happens. How long did that take? Not long at all. Were you right in your estimation?
Call from RCRFF.
More importantly, something else has happened.
Call from RCRFF.
The water in the bottle has gone up. Not much, but it's risen. And I'll prove it to you, because I know it's hard to see from there. See how when I lifted it up, it fell down? Why, I wonder, did the bottle have the water go up in it? Let's try it again.
Call from 57594248081.
So the question is, Why does the water level in the bottle go up after the light goes out? That's it for today. Tomorrow I'll do a demonstration that I used in English all the time. But look at what we touched on. The history of science, the name Archimedes, the value of a cup of coffee. I hope you have a glorious rest of the day. I hope you see me again, you gorgeous people.